This is the part 2 video for the last page of the 2.2c lesson. So again, we're going to look for, I like to start with my y-intercept, which for this one is 5. So I know my equation is y equals something x plus 5. Next, I'm going to look for my m, which is my rise over run, which is up. Well, it looks like it's up 2 boxes, but if I take into account the scale, it's actually up 5 because it goes from 5 to 10. And then it goes over 1 box. And so my m is also 5. In this case, m and b happen to be the same. Number 6. 6 has a similar thing. I need to be careful with my scale. So my starting value is, it looks like 15. My m, which is my rise over run, is up, well, this is 15, so that would be up 5 over 1, 2, 3, 4, 5, and it is actually 5. So that means that's 1. And my equation is y equals 1x plus 15, or y equals x plus 15. Number 7, we fill out a table that kind of summarizes everything that we've been learning about proportional, which was from 2.1, and non-proportional, which is from 2.2. We'll start with proportional. So these graphs looked something like this. And these were linear and passed through the origin. Proportional relationships, y over x ratio is constant. This gave us our COP. And also in a table of a proportional relationship, change in y over change in x ratio is constant. And that gave us our ROC. So in fact, in a proportional relationship, there is a COP and there is an ROC, and in fact, they are equal. Equations for proportional relationships always came in the form y equals mx. So like this, y equals 1x, y equals 2x, y equals 3x, or y equals maybe 1/2x. Non-proportional relationships that are linear look like the ones we saw today. So they are linear, but do not pass through the origin. So the table, y over x ratio, is not constant. And the change in y over change in x ratio is constant. And that was our ROC. So we know that for proportional relationships, there is not a COP, but there is a rate of change. And the last thing was today we saw that for non-proportional linear relationships, equations come in the form y equals mx, and example versions of this would be anything that looks like these, where we have values for m and b that are not 0. If b were 0, it would bounce back into proportional relationships. Feel free to pause, replay this video to fill out this table, which really nicely summarizes. It's almost like a cheat sheet that I would mark or put a post-it or dog-ear this page so you have this for reference as we move through the rest of the module.